believe the quiz was related to the z-score finding for various levels of confidence. And that was related to the little table from the bottom of page. So I think I asked you to get a confidence level of 99%. And to see that correspondence z-score to the level of confidence was 2.575. It turns out that there are three standard level of confidence at which we're trying to estimate population mean. So the average for entire population. We take a sample, and then based on that level of confidence, we have a special formula that says take the sample mean and use it to estimate the population mean by adding and subtracting exact same expression, z times sigma over square root of n. So part of this formula has a z-score that actually is being utilized. And we're never 100% sure. We always make an estimate. So the more confidence we have, the better. And the levels of confidence are here. So there are three possible ones that people usually use: 90% or 95% or 99%. And I asked you for a 99% level of confidence. And to that level of confidence, there is a special z-score that corresponds. But that's all you had to do for the quiz. So find z for particular level of confidence. So we didn't have a quiz. Oh, okay. So there was no quiz then. We'll have one today. I thought we had a quiz, and for some reason I figured, but we didn't have a quiz. We will have a quiz eventually, so no worries. But I guess this level of confidence is something that is good to work with. In fact, this is throughout entire chapter 6. We just started it. And today I'd like to continue using the formula for finding level of confidence. So, for example, try to do one of the exercises in here. Let's see. They have various kinds of stories in here that could be used for practice. And I think that second part of the section that deals with sample size, I don't want to look at right now. I just want to utilize the confidence interval formula. So let us try exercise number 10, for example. That talks about ages of drivers occupying the passing line when driving 25 miles per hour with left signal flashing. So they want a 99% confidence. So for 99% confidence, I just saw the corresponding z-score here. So we're going to use it. So sample size is equal to, so exercise 10. Sample size n is equal to 50. The average in the sample was 80.5 years. And the standard deviation is 4.6 years. 4.6 years. So we can find the interval using our new formula here. So 80.5, we're going to need to subtract the z-score, which is 2.575. multiplied by the standard deviation, which is 4.6, and then divided by the square root extracted from sample size, which is 50. So this is my left side for this interval of estimation for mean. And then we notice that's the same thing, but with a plus sign needs to be entered for the other side, simply because we here and subtract and add exactly the same expression. So I'm going to get a calculator and put this in. 80.5 subtract 2.5, 75, and then times this by 4.6 divided by a square root from 50, right? So we've got 78.82 on the left side, dot, dot, dot. And then for the other side estimate, I have to change, instead of minus sign, to put a plus. So I'm going to just delete this minus and enter plus. And the calculator right away gives us the other side. So it's 82.175, etc. So we did the calculation. The question is, what is that we just found and how we can use it? Because again, the interval we produced does not tell us exactly what the population average is. It's between 78.8 and 92.2 or 82.2, roughly speaking. So if they're talking about the ages of drivers that drive 25 miles per hour with left signal flashing, so whatever this means, we decide at what age possibly this little discrepancy can happen for the entire population. So maybe if there be a driving training course, then you probably want to make sure that this fact is going to be stressed. So people, I guess, try not to do that. So if the average is in between 78 something and 82 something, so then probably you take the worst case scenario. So starting with 78.8 years of age, you will then implement some kind of extra caution into this driving course or whatever this type of study is designed. So the message is, even though we are dealing with the interval, we should always take the worst case scenario, and for some cases is the lowest one, like for this case is the lowest one. And for some cases, it's going to be the highest one. So that'd be probably for some other type of a setting. But the message is, you always can get the idea of estimate related to the real life situation, and based on it, you can always make a little sense out of it. So I can do one more exercise, which is very similar to it. I think I did 11 last time. I can do number 12 here that says, what about level of confidence 95% for exercise number 12? Maybe I can do it on the other side, so we'll have plenty of room. So it's level of 12, confidence of 95%. We have, again, a few pieces of data to deal with, a sample of size 28. And then we had some mean and standard deviation for this sample here. I'm not going to copy them, it's kind of annoying numbers, but we'll use them. But again, once you see the level of confidence, you need to know the z-score that will actually come out from that level of confidence. And to get a z-score, we already know that I just need to look at the tables where the summary on the bottom of this table with confidence levels, there is a summary here. So for 95 level of confidence, 95% level of confidence, the z-score is 1.96, right? So you can just use this summary instead of every time look for the z-score. And then here's my formula once again. So x bar minus z times sigma divided by square root of n, and then on the right side of this interval, there will be same thing, but with a plus sign. So z, x bar plus z sigma, and so forth. So we have formula that may look kind of nasty when you see it first time, but when you look closer, it's only one side that you really care about, because for the other side, in this formula calculation, you're gonna need just to replace the minus sign with a plus sign, so the numbers are the same. And what I do, I just put this in a calculator and added those values. So let me set this up for the left side as usual. So for the sample mean, we use 45 and something like 678. Then we subtract z-score, which is 1.96, and then multiply it by the fraction with a standard deviation of 9,900. That is also divided by a square root from 28. So this is our left end, the lower side. And on the other side, we'll put a plus and the same exact numbers, but then we're gonna need to put a plus, so add them up. Let me enter it. 45, 678. So try to see if I get the right answer. Double check this with your calculator. So times this 9,900, which is divided by square root from 28, and there it is, 42,000 and 10, right? 0.988. So I put 99 because that's in terms of dollars and cents. So I put 99, rounded to nearest cents. And then again, I need to change the sign in my calculator. So I just highlight this and delete the minus and enter plus in its place and get the right end of this interval. It's 49,345. And then again, rounded to nearest cents, so it'll be 0.01. So of course, the key idea is why you need this possibly to calculate, so you can read the story and see that the starting salaries is what they're talking about here for college graduates are considered here. So they want to know what's the average salary for college graduate. So let's say if you go for the loan at the bank, then if you're college graduate, they probably have their own formula, so they will probably go with the lower end because they're trying to be on the safe side. So they say 42,000, and based on this number, the bank may give a loan or whatever, some credit to the college graduate, and estimating the average salary that person will earn right after the graduation. So definitely this is very widely used in the banking business. And please notice that the bank has no inside information of whether the national average for salary is. All they do is they considered 28 existing customers with verified salaries, and based on this sample, they can calculate mean and standard deviation and right away have a estimate for the average salary for that college graduate. And I guess that's very useful procedure for banking industry. And not just for the banking industry. I want to talk about the previous sections simultaneously with this one. So I just want to look at the starting part here. So I want to take a look at the cases where you deal with the population proportion. Because sometimes, remember, we do have average, but sometimes we not talking about the average because it makes no sense to talk about the average, but about the percent. And we saw examples such as elections. So if you're dealing with number of voters for the candidate, well, you're really interested in the percent of people that voted for that particular person or party or whatever. So idea is that sometimes the idea of your sample mean is not really utilized, it's just not applicable. So you can make an estimate for the sample proportion, actually about entire population proportion based on particular samples. So they may poll people and say, you prefer this candidate to the other candidate, and based on the sample they considered, they can make an inferences of who's probably going to win the election. So we have a formula which is very similar to the formula that we had for estimate of population mean. It's so-called estimate of population proportion. And they have here the formula that has take a P, Q, and divided by sample size N inside the square root. And since you don't have the idea about the population proportion, you have to use sample proportion. So we put this little hat above P and Q, because that means that we're dealing with just a sample proportion. And once we utilize this in the formula for calculation confidence interval, notice the similarity of this. It's kind of analogous formula. It has also minus on the left side and the plus on the right. So same exact expression, we add and subtract to a sample proportion. That's why I put a hat above. And the expression is inside the square root, it's PQ over N. So that's analog of the standard deviation over square root of N. So that deals with the z-score multiplied by that particular sample results. So let me get this also calculated here with the sample proportion case. So calculate the confidence interval, but I just want to get a little bit of a story, so it'd be a little bit more exciting to get the some kind of relation to the real life situation. So let's say problem number 27, the internet shopping. So they did the poll of over than 1,000 people. It's exercise 27. And they wanted to see how many people actually do the shopping online. And they noticed that 29% said they use the internet for shopping a few times a year. So 21% or P, which is equal to 0.29 for that particular sample, is a proportion of people that shop online. So right away I can get a Q, the complement of P. So that'll be 1 minus the P with a hat. So it's remaining proportion of people that don't shop online, that just prefer to go to the store, and that looks like 71%. So they say find the point estimate of percentage of adults who use internet. Well, they call point estimate as a P with a hat. That's actually what they gave us. So I don't know why they asked this part A, because it's actually already answered there, 0.29. Well, maybe just to make sure you understand what they're talking about. Now they also say that level of confidence they want to have is 99%. So maybe some company is trying to open its online shopping, yes, some kind of department. And based on this, notice that 99% confidence tells us right away the Z-score. We just used it above, so that was 2.575. So whenever you hear word confidence, you can just get a Z-score down, because that's what I'm going to use here as a part of my calculation. So now I need to set this confidence interval calculation using the formula above. So we put 0.29. So that's a P with a hat, minus Z-score 2.575. For such a high confidence, we get a little bit bigger Z-score. And then inside the square root, it's 0.29 multiplied by 0.71, right, inside the square root. And divide this product by the sample size, which is 1,025. So that's our one side of this calculation. And now I'm going for the other side. And for the other side, well, looks like it's the same thing, but with a plus sign. So I don't even want to write this. I'm just going to change that minus sign with a plus sign, like we always do when calculate our confidence intervals right there in the calculator. So 0.29 minus 2 and little assumption 575, and then I times this by a square root. So numerator is 0.29 times 0.71. This is what we need to divide by 1,000 and something. And we already know that as long as it's multiplied inside the calculator, it doesn't really have to be, that 29 does not really have to be in the numerator, because it goes to numerator when you multiply, when you do this arithmetic. So you've got some decimal. When I say that's just a decimal, yes, that's the way it has to be, because that's a percent of people that shop online. So 0.253 dot dot dot. So percent is always in between 0 and 100%, right? So that's why it's not surprising that we have something like 25%. And now I change the minus sign, I replace it with a plus sign. So here's the other side. So 0.326, etc., is the other side of the confidence interval. And that's the answer. We found the interval. What can we use it for? Well, you can always see what's the entire population of people doing. What percent of people is actually preferring to shop online? So in this case, we have the average somewhere in between a quarter of population or 32, about 1/3 of population. So you can always say no more than 1/3 of people are shopping online, and based from this, you can make all kinds of inferences, right? So again, for I guess, sales business. That's very useful information. And notice that they again found their own sample, and they were able to make such a study. So they estimated how many people actually do shop online, and whether they need to improve their website or other ideas, depends what the study was done for, is definitely bringing some of the better sales, right, into the business. So I guess we see that statistics is pretty much everywhere. That's why I'm so excited about this last chapters in the textbook. And I recommend that you also look at them in a little more details. Don't postpone it till much later, because later we're going to have our exams. In fact, I looked at the calendar and I wanted to look at the calendar with you together, just to show that we, well, don't have much time left for the class. So if I check what's going on now, we have already the second, actually the third week of November, right? And today is Tuesday. So next time I'll keep working on these sections, because there is a little bit more I need to say there. So next time we'll have this Thursday class, and then we're gonna have a Tuesday before the Thanksgiving. That'd be another class meeting. And I plan to give you the final exam on the 6th of December, because I pretty much covered all the material we need. So we're going to do the review on Thursday, the class meeting before, as we did for the midterm. Remember, we had a little test called midterm. I called it as test 1. Now final, I actually want to call this test number 2. It just be a couple of exercise exams, so not too many questions, and I will give you plenty of time for it. And I want to give it to you a little earlier, because looks like I still have some people that didn't turn in their work to me, and I'm patiently waiting and asking to do that if they did not. But if you did, then you're fine. So I'm talking about homework for the midterm. And after the final exam on Thursday, by Thursday, I will grade it and put the grades as usual on the Blackboard. So we'll have another meeting on Thursday, and then I can work with those people that missed something or wanna get a better grade, or whatever else needs to be discussed or argued. So that's why I always trying to discuss the grade before I put it in the system. So on Thursday, after final, we'll meet and we'll see what needs to be done. If you want to improve your grade, some people say, Alex, I want to improve my grade. I'm fine with that. I'm willing to work with you on this, and that's why I give extra time. And I think it works, because if you have more time, you have more chances to do a better in class. And I just never mind that. I think it should be supported. And that's why we'll have our final on the 6th. So I will finish up with the material on 17th, then with these sections. Maybe we'll cover another section on 22nd. There is one more that I wanted to look at. And then 29 will be wrapping up with everything. And then we'll start discussing the final. And if you can't be in class, just check a recording, because I do record lectures, and shouldn't worry about this. And you know how you can always fix this, right? If you miss a quiz, then you can just check a recording and see what was the quiz and send me the answer. I accept it, so it's not a big deal. But just make sure you take it seriously, especially by the end of semester. And that's actually why I started this talk, because it's end of semester, so you want to push up a little bit harder and to get the best possible result. So I think that's very important that you know this, and you should also be aware that I'm here to help you to get the best grade. That's why I will inform you what your grade is, and if you want to improve it, or if somehow I didn't receive some of your work, well, just send it to me. In fact, sometimes I ask people to send me their work. Well, maybe it just didn't go through. So don't get upset and say, Alex, I already sent it to you. Just stop it. Well, if I ask you to send me your work, well, it means I didn't receive it. So just to make sure that I receive all of your work. Because if I don't say it to you, I'll just not going to include it in your grading. And I think it'd be unfair to you. So that's why I try to make sure that I get all of work, especially with online environment. Lots of things may happen because of technology glitches or whatever, power issues. And that's why one needs to realize it. Whenever you take the online class, it's not same as if you're taking face-to-face class. It's different. You need to be a little bit more careful and probably more dedicated and sending all of this work to your instructor. Make sure you send it to the right email, because sometimes people send it to the wrong email. And so there are various little issues. And that's why I think it's important that we work them all out. So anyway, so we are in a good shape for covering the materials. That's why I think 3 more class meetings will be done with everything. Then we'll do review. The final will be same as a midterm, 2-question exercise, and we'll have plenty of review before it. So that's pretty much all I wanted to say here. And then over Thanksgiving, I will be updating your quiz and class scores. So before the final, you will know for sure what grade you are getting, because I know that we already had a few quizzes after the previous time I updated your grade, and some people turned in some more of their work. So I will definitely update it over Thanksgiving weekend. In fact, I'm still waiting, and I hope that some people that did not send me their homework for the midterm, they will send it. And I guess that's pretty much all I wanted to say. In the remaining time, I need to ask you to fill the student evaluations for this class, because I believe that you should have received the email from college with a link to fill a student evaluation, and not just for this class, for all classes you're taking in our college, or pretty much all classes you take in this semester. It should have been sent to you on Friday last week, I believe. So if you didn't fill this evaluation, could you please do it right now? And I devote some of the class time for it. Of course, I'm gonna stop the class meeting right